Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning or good afternoon to everyone. I am Ridhwan Jumaidin from Universiti Teknikal Malaysia, Melaka. Today I'm going to present my paper entitled Thermal and Mechanical Properties of Thermoplastic Cassava Starch Beeswax reinforced with Cogon fiber. Okay, so as the outline, the presentation will consist of introductions, various polymers, thermoplastic starch, modifications of the thermoplastic starch, the methodology used, the results, and also the conclusion. So as the introductions, nowadays most material used in plastic industries are produced from synthetic polymers that obtained from fossil fuel. So this materials is a non-degradable and non-renewable natures. So it has created a very serious environmental problems, as you can see in this picture here, where all the plastic is not degradable and it has polluted the rivers, okay, somewhere in Philippines. So every year around 500 million plastic bags were used, and as much as 1 million plastic bags are being disposed for every minute. And I believe that amount is increasing year by year. So these plastic bags are difficult to dispose to the environment, especially like soil, ocean, lake, where it takes around 300 years to photodegrade. And when it degrades in water, it will pollute the water. So it's convey difficult issues to the human being, wildlife, and also for environment. So as the alternative solutions, biopolymers were introduced by researchers. Biopolymers are made from natural resources. It seems to be a promising approach because this material is readily biodegradable and thus is more environmental friendly than the conventional polymers. So among all the biodegradable polymers, starch is been reported as one of the most promising due to its easy availability, biodegradability, and also renewability. So the interesting part about starch is it can exhibit thermoplastic behavior with the addition of plasticizer, heat, and also shear. So to develop plastic from starch, the granular structure of the starch must be either totally or halfway destroyed under high temperature and shear with the presence of plasticizers such as glycerol, sorbitol, water, and others. So this is the granular image of the potato starch. So this is how we develop the thermoplastic starch, where the starch and glycerol will mix. Okay, and then these were put into the mold and then undergo hot pressings, and then this material will transform into a clear plastic materials where the name can be called as thermoplastic starch. Okay. See, so starch can act as plastics. Okay. However, there are some problems with starch where the strength is extremely poor, and then the blending of starch with other material is necessary to improve the strength and the stability. So we came up with the reinforcement by using natural fiber to improve the properties of TPS. Okay, so what is Cogon grass? Cogon grass, also known as Imperator cylindrica, is the richest grease-shod plant in tropical countries, including Malaysia. It grows wildly in the rainforest. So Cogon grass plant size grows is about 1 meter tall and leaf rough. So this plant generally has no economic rates, and it's one of the biggest problems for agriculture. So this is because the planters must spend a lot of energy, particularly spending money, time to control their population, and to eliminate competition from agroeconomic plants for nutrients, water, and also light. So this is one of the problems encountered by the planters in the plantations. So, and there is no value for this cooked grass. In Malaysia, we call it as a lalang. So, come back to the thermoplastic starch. Okay, in this study, previously we have modified the thermoplastic cassava starch by using Beeswax. Okay, and then you can see here that the Beeswax is able to improve the stiffness of the thermoplastic starch. And then there is no big impact on the structure of the materials. So Beeswax is able to improve the mechanical and also the moisture barrier, and also reduce the water solubility which means increase the integrity of the materials. So for this study, we are not using the pure thermoplastic starch as the polymer matrix, but we are using the polymer matrix blend, which is the Beeswax, as the base material for this composite. And then we mix it with the coconut grass fiber to investigate what are the performance of the coconut grass fiber when it's mixed with these bio-based materials. So we raise the loading from 0 to 40%. And then for the methodology, for this study, we are presenting two types of testing, which is thermogrammetric analysis by using the GA machine. And then for the tensile mechanical properties, we are presenting the tensile test results by using the UTM machines. So as a result for the TGA, as you can see from this picture here, the one with the higher percent of fiber loadings, it stays on the top, which means that these materials has better thermal stability as compared to the material with no fiber, which is 0%, is on the top, on the bottom. Okay, so you can see here it's a good indicator which shows that adding the natural fiber able to improve the thermal stability of the materials. Okay, so let's see here what the information given. So the first phase of regulation the temperature from 0 to 200. Okay, this normally in these regions is normally attributed to evaporation of water and glycerol, and after that the weight loss is about 150 to 180, mainly attributed to the decomposition of three major chemical components such as hemicellulose, cellulose, and lignin for the natural fiber. And then for the temperature up to 300, it's due to the thermal degradation of starch carbon chains. So it's around the peak here. Okay? So basically, if you see these figures, this is the DTG figures, it is clearly visible that the first peak of the composites after its maximum combustion, after integration with CGF, was slightly deviated into the lower temperature. Okay, as you can see here, which is compliance with resorption into GKF, implying that it enhanced the thermal stability. As you can see, it's slightly shifted to low temperature, and then the peak here is, as you can see, this peak is reducing. The intensity was reduced from the 0%. This peak is reduced to the lower derivative rates, which means that the maximum decomposition was decreased following the increase of CGF content. This is because this decomposition was mainly attributed to the starch decomposition. Okay, so addition of fiber enhance the thermal stability, and the fiber matrix adhere properly, reducing mass loss in the sample. Okay, in terms of the mechanical properties, as you can see in the figure here, the strength was increasing. It's significantly increased. I can say that it's about from 2% here until 10%. So it's 5 times of improvements in terms of the tensile strength when we employ the coconut grass fibers. So this can be associated with the reinforcing effect of CGF, initiated by the interaction between the TPCS matrix and the coconut grass reinforcement, and by the good surface weighting morphology. However, there was a slight reduction at 40% of CGF here. This can be attributed to larger or higher content of the fiber. For the tensile modulus, it's very good improvement. The material become more stiff, more stable. So according to previous study by Saripudi, it was anticipated that the fiber addition would improve the modulus due to the inclusion in the soft matrix of rigid filler particles. So therefore, this finding suggests that the fiber inside the composites existing to have the stiffening effect on the materials. And in terms of the elongation, this is the normal effect when the tensile strength increase. So it will affect the elongation or the ductility of the materials. It will reduce. So the elongation began to decline when 10% of thermoplastic fiber is added into the TPCS matrix. So the declination continues until 40% of the cone grass. So the lower concentration of starch that leads to decrease in the elongation in breaks. So as the conclusion, the biopolymer composites derived from cassava starch, Beeswax, and also cone grass fiber was successfully prepared by using high-speed mixing and hot press. So the thermal properties were evaluated and indicates that it improved the thermal stability of the composites. And same goes to the mechanical properties. So the conversion of TGF essentially enhanced the tensile strength and tensile modulus, but decreased the elongation. So overall, the finding shows that the addition of cone grass fiber has improved the functional properties of these materials. So as the acknowledgement, I would like to express sincere gratitude to Universiti Teknikal Malaysia Melaka and the Ministry of Higher Education for the financial support provided through research grant GSA 2019 FKMP K801413, and the conference proceeding was supported by a publication incentive grant, Journal FPK 2018 Q0004. So that's all from me.